Okay, I have before me the 9-point circle, and I'd like to give a little bit of explanation as to what's going on. Let's see how this works. Start by selecting this, moving this circle out of the way, and moving this triangle out of the way. So, what do we have? We started with any old triangle. Able to delete this. Okay. We started with any old triangle, ABC. Looks a little bit complicated. I dropped the perpendicular from A. That is, I drew a circle around A that went past below the line BC. And I found the 2 points where it met, and I came up with congruent circles around each of those, and where they met, I was able to drop a perpendicular. And I dropped a perpendicular from B to AC, and from C to AB, and as we talked about before, they're all going to meet at this one point. Next, I subdivided each of, I took this point, and then between each vertex, between A and the place where the three altitudes meet, I found the midpoint, A double prime. And between B and where the three altitudes meet, I got B double prime, and between C and where the three altitudes meet, I got C double prime. Now, what is so exciting about this? What is so exciting about this is that if I connect a line from B double prime to C double prime, this is in the triangle B, what's that, HC, this is proportional because B double prime is the midpoint of BH. That means that this little triangle is a 1/2 scaled version of the big triangle, and that, so this this side is 1/2 of HB double prime is half of HB, and HC double prime is half of HC. So that, and this angle is the same, and that means that HB double prime, C double prime, and HBC are similar triangles. And if they're similar triangles, then this angle is the same as this angle. So this line is exactly half the length of BC, and it is parallel to BC. And because AD is an altitude at a right angle to BC, that means that this is also at a right angle to it. Now, if I connect C prime, the midpoint of AB, and B prime, the midpoint of AC, by the exact same argument, we see that this line is parallel to BC and also half the length. So these two lines are parallel to the same line. They're parallel to each other. They're the same length. That means that if I connect their endpoints, I will get a parallelogram. But that's not all. If I look at the triangle AHB, C prime is halfway between A and B, double prime is between B and H. That means that again we have this BC prime, B double prime is similar to BAH, and so this line, C prime, B double prime, is parallel and half the length of AH. And if it's parallel to AH, it is also perpendicular to BC in these two lines. So not only did I make a parallelogram, but this C prime, B double prime, C double prime, B prime is a rectangle, and it looks pretty rectangular right there. And furthermore, it's not only a rectangle, but if I take its two diagonals, they're going to meet at a point that we're calling O. And now this point O is going to be the same distance from C prime as from B double prime and C double prime and E. So if I come back and get my circle, where's my circle? If I come back and get my circle, a circle centered at O that goes through any of those 4 points will go through all 4 of them, because the center of a rectangle is equidistant from all 4 of its vertices. Now, if we do the same thing with any of the other points, do I have all the other points in here? Let's see. Like if I connected the midpoint of A to H, this point to this one, this would be half the length of AB, because this triangle, this big AHB and A prime H B double prime has A double prime, and that we'll make a rectangle. We'll also make a rectangle with these 4 points. And the cool thing about this rectangle is it has the exact same center, because one of its diagonals is B prime B double prime. So the center is going to be the same center as that last rectangle. So this circle is going to go through not just B double prime and C double prime and B prime and C double prime, but it's also going to go through the A prime and the A double prime. Now furthermore, and finally, cancel. Finally, if I make these things go away, I don't need these. But we have this is one of those diagonals. A prime, A double prime is one of these diagonals, goes through the center. But if you look at it, this diagonal through the center, we know for a fact that because A down to D was an altitude, it meets BC at a right angle. And that means that this triangle, A double prime, A single prime, D, makes a right angle. And we know that in a circle, if you take the diameter and you go to any point on the circle, it will always make a right angle. No matter how you do it. You go to this point and then over, that will be a right angle. It always makes right angles. And because of that reasoning, it's in the notes and more clear, this point has to be on the circle also, because it's going to make a right triangle at that point. If we had a right triangle in or right triangle outside, from this point being outside, it's not going to work. The point being, that means that this D, the foot of the altitude, has to also be on that circle. And by the same argument, the foot of this altitude, CF, is going to be on the circle. And even though it's barely there, BE is going to be there. So every circle, is going to have, every triangle has what they call the 9-point circle. A circle that goes through the 3 feet of the altitudes, the midpoints of the 3 sides, and, slightly more complicatedly, if you find the place where the 3 altitudes meet and you go halfway to any of the 3 vertices, it will go through those midpoints as well. I hope this helps.